Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela Tran here, and today we are going to do some practice problem of section 7-1, the advanced level. Let's look at the first problem. You are given the first information. The current stock price is 50. The second information, the stock pays dividends continuously at a rate proportional to its price. The dividend yield is 2%. The third one, the continuously compounded risk-free interest rate is 3%. And the last information is the following 6-month barrier on option prices are Dow and in call with a barrier of 48 and a strike 52 has a price of 3.2031. Dow and out call with a barrier of 48 and a strike 52 has a price of 1.6404. Dow and input with a barrier of 48 and a strike 52 has a price of 5.7879. Calculate the price of a 6-month Dow and out put with a barrier of 48 and strike of 52. So to summarize, we see the stock price here S of 0 is given at 50. The dividend yield rate delta is 2%. The continuously compounded risk-free interest rate R is 3%. And we have 4 option prices. All of them have the same duration of 6 months, the same barrier of 48, and the same strike 52. The reason that all of these are called Dow is because we consider the downward barrier of 48. You say that the barrier of 48 is less than the strike. That's why we are considering the downward barrier. So we are given 2 call price and we are asked to find the put price. So of course we have to use the put call parity because that is the only formula that make connection between call price and put price. But the question don't give her the ordinal call price and the ordinal put price. So we have to find the ordinal call price and the ordinal put price. Ordinal call price is equal to the Dow and in call plus Dow and out call. Similar, if you have up and in and up and out, then ordinal call should be up and in plus up and out. But in this situation, we are considering the downward barrier. So the ordinal call is 3.2031 plus 1.6404. This is 4.8435. Now similar, we have ordinal put is Dow and input plus Dow and output. We got 5.7879 plus X. X is the price of a 6-month Dow and output with a barrier of 48 and a strike of 52. So that is what we are trying to evaluate. I repeat, this X is what we have to evaluate. Now let's apply the put call parity. We got call minus put is 50 times e to the minus 0.02 over 2 minus 52 times e to the negative 0.03 over 2. Because 50 is the current stock price, 52 is the strike, delta is 0.02 and R is 0.03. The duration T is 1/2. 6 months is just 1/2 of year. And this equal to negative 1.7233. Now the call price is given at 4.8435 and the put price is 5.7879 plus X. So from here we have a new equation, but this is simply just a linear equation of X. So we got X is 0.78. Problem 2. For a certain stock, investor A purchased a 45 strike call option, while investor B purchased a 135 strike put option. Both options are European with the same expiration date. Assume that there are no transaction costs. If the final stock price at expiration is S, investor A's payoff will be 12. Calculate investor B's payout at expiration. If the final stock price is S, okay, so in this question we have two investors. The first investor purchased a call option. So the payoff of the investor A option should be S minus 45 because it's a call option. And if the value is negative, we take 0 as the answer. Otherwise, we take S minus 45. And here the payoff is given at 12. So we got maximum value between 0 and S minus 45 12. Of course, 12 cannot be equal to 0. So 12 should be equal to S minus 45, which means S is 57. So now we know the stock price is 57. And use this information to find the payout for the second investor. We got payoff is equal to maximum between 0 and 135 minus S, which is equal to maximum of 0 and 135 minus 57. It is equal to 78. So the answer here is 78. Problem 3. Let CKT and PKT be the prices of a T-year K-Drive European calls and puts of a stock. The stock pays no dividends. The call price with a try 50 and duration 1/2 is equal to the put price with a try 50 and duration half year. The continuous compounded risk-free interest rate is 10%. Find call C52.2 minus P52.2. So again, the only formula that make connection between call price and put price with the same strike and duration is the put call parity. So I'm going to apply the put call parity to the first group first. We see C50.5 minus P50.5 is equal to 0 because the question given they are equal. And if we use the put call parity formula, we got this equal to S0 minus 50 times e to the negative 0.1 times 0.5 because R is 10% and T is 0.5. So S0 is equal to 50 times e to the negative 0.1 times 0.5, which is equal to 47.56. That's the current stock price. Now use it to find C52.2 minus P52.2. Again, by put call parity, we got C52.2 minus P52.2 is equal to S0 minus 52 e to the negative 0.1 times 2 because R is 0.1, T is 2, 52 is a trike, and S of 0 is 47.56 from the previous step. So we got this is 4.9875. So the answer is 4.9875. Problem 4. The current price of a non-dividend paying stock is 40. The continuously compounded risk-free interest rate is 8%. You are given that the price of a 35 strike call option is 3.35 higher than the price of a 40 strike call option, where both options expire in 3 months. Calculate the amount by which the price of an otherwise equivalent 40 strike put option exceeds the price of an otherwise equivalent 35 strike put option. So in this question, we are given a non-dividend paying stock, so delta is equal to 0. The current stock price is 40, S0 is equal to 40. R is 8%. And if we consider 2 call options with the same duration, 3 months, but different strike, then the price is different by 3.35, which means C35.14 minus C40.14 is 3.35. And the question asks for the amount by which the price of an otherwise equivalent 40 try put option exceeds the price of an otherwise equivalent 35 try put option. So we got P4014 minus P3514 is what we have to evaluate, and I call this X. So our job is to solve for X. Now, the only way that we can make connection between call price and put price just using the put call parity. But both these two equations, we have call and put. We don't have call and put. So we have to combine the equation by either subtract or add. Here I want to have call subtract put with the same try and duration. So I have to add side by side. So if I add side by side, I got call 3514 minus put 3514. Subtract, I open the brackets. I have call 4014 minus put 4014. This is equal to 3.35 plus X. Just left side add left side, right side add right side. And from here we solve for X. So from here, at each group we use the put call parity. For the first group, we got the current stop price 40, subtract the try 35 times e to the negative 0.08 over 4. The second group, the current stop price is 40, but the try is 40. So from here, we have 4.9 is equal to 3.55 plus X. And solve for X, we got X is 1.55. So the answer is 1.55. Problem 5. A stock has a time t price of S of t. You are given the following values of S of t. T is equal to 0. S of t is 100. T is equal to 0.25. S of t is 97. T is equal to 0.5. S of t is 102. T is equal to 0.75. S of t is 96. T is equal to 1. S of t is 104. T is equal to 1.25. S of t is 110. T is equal to 1.5. S of t is 120. T is equal to 1.75. S of t is 120. And T is equal to 2. S of t is 108. Calculate the payoff from a 90 try arithmetic average price call that are based on quarterly stock prices over 2 years and matures 2 years from now. So here we have a data set of 9 different values. However, in order to calculate the average over the arithmetic average price call, we do not count the initial time because the stock is issued at time 0. So we have to ignore the number 100. Now, in order to find the payoff, we have to first find the arithmetic average price call. So we have to take the last 8 numbers, add them all together, and divide the sum by 8. And then we take the the arithmetic average price call, subtract the trike. So we got 17. And because 17 is positive, so of course the payoff is 17. If the number here is negative, then the payoff should be 0 because the payoff is non-negative. So the answer to this question is 17. Alright, that's it for today. Thanks so much for watching. I hope you guys enjoyed my video. See you on the next video. Bye bye.